Okay, for these next set of problems, we're going to go ahead and just omit number 3. We can do it, but it comes off the graph. So I'm not going to stress that. We're going to show some steps. So it's okay if you skip it. If you get a graph tomorrow and it goes off the graph, just ask for some more graph paper and we'll make it bigger so it can fit. So same kind of thing. We got to do slopes. We got to do distance. The same process that we did on 1, 2. So I always start off graphing your points. Okay, I've graphed and labeled. Don't forget your letters that they give you to represent the point. So here we have here, and I think most y'all, once you go and you look at it, they're gonna say, this looks like a rectangle. I want to pick that. If you just do the points, this graph, that and the answer, that's only 2 points tomorrow, okay? So you have to do your slopes. You have to calculate your slope. So we're going to start off with the slope of JK. I mean KJ. It's the same thing, okay? Lowercase and KJ. Count your rise over run. I'm going to do that in red so you can maybe see. Our rise is how many units we have to go up to get to the same level as J. So that's 1, 2, 3. That's 3. So that lets me know that on the top of my ratio, I'm going to have a 3. Up is positive, down is negative. Then I'm going to count how many units I have to go to the right or left. I'm going to move to the right, so that's positive, to get to this J. So this would be 1, 2, 3, 4, 5, 6. 3 over 6. As long as you get to here, you're fine. Now, we would hope that you can see that that reduces, but if we get to here, we're good, okay? Now we're going to do the same thing for each side, okay? We're going to do that for JI, okay? And so I'm not going to necessarily color code it every time. I'm just going to count from J to I. J means I'm going down 1, 2, 3. That's negative. Oh, actually 1, 2. And then to the right 1. So that would be negative 2 over 1. And now I'm going to do the same thing for I to H. I'm going to count. Now I can start at I or I can start at H. It doesn't matter. This is the same segment. So I'm going to count. If I start at H, I'm going up 1, 2, 3 to get to the level of I. And then I'm counting over 1, 2, 3, 4, 5, 6. All right. And so hopefully we see we have the same number here, 3 over 6. And then same thing for the slope of KH. We have 2, negative 2 over 1. Now, this is important because if I see that they have the same slope, see 3 over 6 is the same thing as 3 over 6. These are opposite each other. They're parallel. So I need to know I'm starting off with the parallelogram. What I have to check is if it's of a rectangle, then we have a right angle. We have to have perpendicular for a rectangle. You also have to have it for a square, okay? But it's not a square because we don't have the same numbers here. A square, we have all sides, they're congruent, and we don't have the same numbers. Now, I'm hoping you see that this 3, 6 is the same as 1/2. 1/2 is the opposite reciprocal of a negative 2. So it is perpendicular. Okay, so this is true. That happens. So I know I have a rectangle. Okay, because the slopes are parallel, opposite slopes are parallel, and consecutive sides are perpendicular. And we're done. Okay, so sometimes you don't have to do every step as long as what you do on step 1 justifies your answer. So if you have this, your graph, that's 2 points, and you have your slopes showing that you have opposite sides parallel and showing you have perpendicular, that's your +4, and that takes care of the whole problem. Okay, so here's 5. Got a graph for you. If you want to pause the video and check your graph, you can. I'm hoping you can see that this physically looks like a trapezoid. For it to be a trapezoid, only one pair of opposite sides are parallel. So everything goes back to our slopes. So we're going to do the slope of HI again, or IH. It's the same thing. So I to H means I go up 1, and then I'm counting to the left 1, 2, 3, 4, 5, 6. So 1, negative 1, 6. And then I'm going to look at my slope of IJ. From I to J or J to I, I'm going to start at J, up 7, and then to the left. So that is 7 over negative 5. And then we're also going to do the slope of GJ. So from J to G, I'm going up 1, 2, 3. So 3, yeah. and to the left. Yeah, so this is 3 over 18, and it's a negative. 3 over 18 reduces to 1, negative 1 over 6. So right now I see these are the same, so I have proven it is parallel. You can only have one set of parallels if it's a trapezoid. Well, I got to still check the last side. The last side is my G to H. I count my G to H. That means I go up. If you want to physically see this again, 1, 2, 3, 4, 5. That keeps me even with H. So that's a 5 units up. And then to the right, 1, 2, 3, 4, 5, 6, 7. So that would give me my slope of 5 over 7. And these two are not the same. They're not parallel. They are just reciprocals. Okay? They are actually they're opposite reciprocals of each other. So eventually they would be perpendicular. So we show at least only one pair, only one pair of sides parallel because they have the same slope. That's what we're looking for. Same slope, same slope. So on here, I forgot my letters, so let me get it on here. We have, what was it, -3. We start with, this is my P. I believe this is my Q. This is my R. This is my S. Order is important. You go in your order. And now I'm just going to do, again, the slope of each side. So I'm counting. This is PS. That's 6 over 2. That's the slope. Now I'm going to do PQ. This is -2 over 6 right there. I proved right there those two are a flip and a change of opposite reciprocals. So now I know it's perpendicular. And perpendicular happens with the square and with the rectangle. But because we are using the same numbers, okay, see how we have the same numbers? So like if I would find the length of PS, that's when we do in our parentheses 6 squared and parentheses 2 squared. So this gives me, underneath our radical, our house, inside the house is 36 plus 4, which was give me a square root of 40. Well, that would happen the same thing for PQ because a -2 squared is still going to end up being a positive. And we also have a +6 squared, so it comes out to be the same. So now that I know these are all the same, my answer is square. But please know, if you just look at it and answer it, that's only 2 points. Okay, that's only 2 points. So that takes care of that section. Now, this is a whole nother section where order matters. So we're going to continue on this using our slopes. Everything is derived from our slopes. And I went ahead and graphed the points. And so I'm talking about order matters. You connect in the order that they give you. G, H, I, J. Okay, so I start at G. I go to H. Then I would have to go to I. Then I have to go to J. And then I would come back to G. Okay, so this I has to be somewhere over here if I'm going in order. This is where we use our slopes. So I know I is opposite G. And IJ would be opposite GH. So I'm going to count 1, 2, 3. That's my rise of 3. And I'm going to count over 1, 2. That's my run of 2. I'm going to do that same thing starting at J. 1, 2, 3. And then my run over 1, 2. And that lets me know where I is at. So we have I is now going to be at the order pair. See 3. I is at 8, 4. Okay? We're going to connect it. Now, that's the first part. The second part is they want you to find the y-intercept from G to I. So what we're going to do is we're going to connect it. Here's G to I and extend it if we have to. We want to know, where does that line cross the y-axis? Well, it's right here at 0. So our answer for our y-intercept, answer is 0. Okay? Now, on number 8, we have to, there's a little typo. It's not supposed to be negative, it's supposed to be positive. So I went ahead and graphed them. And remember, order matters, so we're going G, H, I, J. So G gets connected to H, which gets connected to I. I gets connected to J. So J has to be somewhere over here, okay? We're going to use our slopes again to get to that J. Well, I know it's opposite this HI, so I'm going to count my rise. That's going to be a rise of 2 and a run of 2 to get to that I. So I'm going to do the same thing starting from G. Rise of 2. Oh, that should have been red. Sorry. Rise of 2 and then a run of 2. And hopefully see here is where our J should be. So we can connect it because it's a parallelogram, so opposite sides are going to be with the same slope. So hopefully we have 4, is it 6? Yeah. So J is 4, 6. Now they want us to find the y-intercept of HG right here. Y-intercept of HG. So I'm going to take this side HG and I'm going to extend it till it crosses the y-axis. And my line might just be a little off, so let me just check this real quick. So our slope is actually 2 over 1. So this 1, 2 over 1. So my line is off. It should go right here. That's where it should cross. So your y-intercept, because if I follow the slope, this is up 2 over 1, up 2 over 1, up 2 over 1. So that lets me know that my y-intercept is at 6. Okay, is at 6. So what I'm going to have, I'm going to do one more, and you're going to be responsible for number 10. Okay. So I plotted the points. Remember, order matters. So we have A, B, C, D. So I'm going to go A to B. B goes to C. C would come to D. D comes back to A. So C has to be somewhere over here. Hopefully you see that if you go in order. So we're going to use opposite slopes to parallel, meaning same slope, because we have a parallelogram. So I'm going to count from A to B. 1, 2, 3, 4 is my rise. And then I'm counting 1, 2 is my run. So I'm going to do that same thing starting at D. 1, 2, 3, 4 is my rise. And 3 is my run. So we should see our point is right here for C. We're going to connect them. Give the order pair. C would be to the right 1, 3, 4, 5, 6, 7 units. And then up 1, 2, 3, 4, 5. So it's 7, 5. And now they want the y-intercept of B to D. So now I got to connect that. Here's D to B right here. We're going to extend it out till it crosses the y-axis. And I'm hoping we see, I think my line, let me fix my line a little bit. Let me fix it. There it goes a little. I didn't go through the point action. Let's undo that then. Oops, what did I do? Apologize. So it's a 1-to-1. So right, oops, right there. Yeah, it's going to end up crossing right there. I need to move this up just a little bit. How about I do this? Let's actually do a line. I apologize. There's my line. There's my option. There's my color. I think. Nope. Or maybe not. Okay, here we go. There is the line, and we can now see that it does go through the y-axis at 7, I believe. Yeah, or 6. Yeah, at 6. So again, our y-intercept is 6. All right, so you have number 10. All right, thanks for taking care of that. Oops. And we'll do another fast forward if you need to get to the next problems, 11 and 12, which were like 1 and 2. Same step, same step, same step, same